Good morning and good afternoon, everybody. I hope you're all staying safe. While this is not the usual delivery we were planning on doing in Austin and in London, I hope we can still keep it as engaging and interesting as possible through these virtual presentations that we're pretty much getting used to, I guess, everybody. Right, so today I want to talk about two topics. Well, it's one topic really, it's all about AI and testing, but I want to talk about the two sides of this, the two sides of the coin around AI and testing, which is one, how we can leverage and use AI and machine learning in testing. And on the other hand, how can we actually use testing for AI, for improving AI, for better quality of AI. Let's start with the first piece of research that I'm going to share with you. And I actually did this research, started actually at the end of 2018 and published at the beginning of 2019, this first report, which you can see the conclusions of in the title, which is basically that as testers, as developer testers, persona testers, business persona testers, or technical testers, we are going to be augmented by AI in testing. And so in other words, we will be leveraging AI intelligence coming from bots that are going to be helping us get our job done better rather than being replaced. So in this research, Forrester, we do a lot of data surveys. One of the questions we asked to developers and testers in general around the world is to tell us where they felt AI and machine learning could be leveraged in the whole software development lifecycle. And as you can see here, 37% of them claimed that they were using and they planned on using AI and machine learning in the test stage, in the test phase. We also got high interest, as you can see by the blue duck color, on the deploy side, and actually on the operation side. It's more the AIOps that everybody hears about, that we all hear about today, which has the goal of making operations more resilient and predicting problems from happening and actually automating the prevention. But let's talk about the testing space, because that's what we're here to talk about today. And in the testing space, of those 37% that responded, yes, we are planning and we are doing something with AI and machine learning in the test area, you can see that if we carve out the 61% respondents about improving and using AI machine learning to prevent incidents in production, the other areas where AI and machine learning has been used and is being used is to augment testers' capabilities with, during the whole testing process, improving the test management process and test strategy by identifying ahead of time what needs to be tested, what type of automation can be done or needs to be done next, optimizing the whole test process and the whole test process. And there's 26% that, so 50, the majority, 50 and 41% were looking at this optimization of testing, optimizing the test strategy, the test management process. But 26% are using machine learning and AI to improve the way we automate and how we automate. And then only 10% actually came back saying, well, we are using AI to test AI solutions. All right, so let's focus on the use cases. So there's two things that came out of the research. One, the use cases where AI and machine learning is being used and for gaining some benefits that we will describe in a minute. And the other one is a maturity model that I'm going to share with you on trying to kind of identify what are the different levels of maturity of automation we can gain to reach level 5, as you can see on this slide, for full autonomous testing. So the main drivers I used to categorize these use cases were based on the fact that there were either multiple deployments at large enterprises, or that there's a decent ecosystem around the use case with not just vendors building and embedding AI and machine learning in their products, but also service companies, service testing companies leveraging AI and ML to deliver better testing services to their clients. And so consulting companies and, looking also at what's being done in the research community. Another driver on placing these use cases between those that are mostly a reality, meaning can be used today, and mostly a myth, which you maybe want to experiment or wait to really deploy. But another important driver was how mature was the technology. And how mature was the technology in this case meant, you can see that in AI, that different technologies have different level of maturity and different level of usage. NLP, for example, natural language processing, is an area where there is more, where more maturity is needed. It's harder to really have complete full grade natural language understanding between different languages, translation of languages, and understanding of full semantics in the way we speak every day, the different tones, etc. It's improving, but still, that technology has to improve, right? And then looking at those tools that we're using, the technology, types of technology use cases that would leverage things like predictive learning, or machine learning, simple statistical machine learning algorithms, or deep learning algorithms as well. Okay, so what are the use cases? Let me talk about a few of them. On the most reality side of this graph, you can see visual testing. Well, visual testing, I guess it's no surprise to you, because there's this technology is being used now quite extensively for better user interface recognition, and therefore for testing. It gets much better. It's much more precise than the traditional technologies that have been used. It helps identify really false positives and false negatives. Companies like Tools have been offering this now for quite some time, but also other vendors are embedding this technology in their test UI, in their UI test automation tools. Another close to reality use case, important use case, is automated test generation. Now, this is a reality only because if you think about the domain, the DSLs, right, having a domain specification language, or which can be infused with some natural language and keywords and testing. So infusing the domain specific language with more natural language structures and keywords is something we do already. I mean, some of you might argue actually that cucumber could be placed in this cucumber gherkin, right, language. Well, these are kind of a cucumber, a behavior-driven type language, but with more infusion of natural language in. Now, if we keep the domain scoped, if we keep the language usage with which we need to do within the policies that companies might have in terms of how they want eventually language to be business language to be leveraged, then it's mostly a reality. On the opposite side of this use case, you'll see the full test design and generation, basically where we're going to be able to write requirements in full English and generate test cases from there. But that's mostly a myth at this point. In between mostly a reality and mostly a myth, you can see things like API test generation from while you navigate the user interface, the system generates API tests, making it easy even for those that are not developers to be able to test APIs. Defect management and clustering. This is also becoming more and more common, which is being able to cluster the defects that are encountered in production, leveraging log files, leveraging data from the testing tools, and crunching all that data and finding out, the different categories of tests and the types of fixing that would need and who those tests can be fixed by, reducing mean time to repair. Test lifecycle optimization is a real interesting one. In other words, supporting us in what to test and what to automate. Now, the reason that's kind of halfway between a reality and a myth was a year back when I did this research, because it requires using machine learning, especially more sophisticated machine learning, requires a lot of data. And so so that was a challenge. But I would say that that kind of has been shifting a bit more towards becoming more of a reality, because there are cases where that data is now becoming available. Think about and some vendors are leveraging this. Source Lab, which is sponsoring this speech, is one of them, for example. Because with all the data, imagine all the data that is generated on the grid, to help define, help leverage the insights coming from that data to do a much better, efficient job at what to test, when to test, and execute the actual automation and testing of it. There's another couple of things that I've added, since I wrote the research. One is smart automation execution. So I am seeing leveraging machine learning algorithms that will learn from all the checking. Every time we check code in and we run tests and look at the regression tests, and based on changes, we'll kind of identify every time you do a check-in which tests to actually execute and which not. Self-healing is another area. Now, self-healing UI tests, you might consider it to be a bit too optimistic, being positioned as mostly a reality. But if you focus only on the self-healing at the user interface level, that is a reality. Many tools now start offering this feature, which means things like, if an object in doing UI automated testing, sometimes what happens, especially using Selenium, that the test breaks because the object location changed. And what this self-healing does, it will actually make it more resilient, make the UI locator change more resilient, or enable some path analysis that will help identify a new object coming up on the screen that was not recognized before, or was not in the library of the standard objects that are recognized. So self-healing, restricted to UI tests, a reality. I expect much more to happen in the self-healing space, but that would be more of a myth. All right, so let's look a little bit about this maturity that I was talking about. It's inspired to the SAE International Self-Driving Car Standards level defined in the United States. And there's three things I just want to highlight here. One is that from level 0 to level 4, human drivers are in control. Level 5 requires full automation. It's like the Google car with no possibilities for the human to intervene in the driving, and the machine is totally in control. Another important aspect. So that's aspect number one, right? So human beings being in control from level 0 to level 4, and level 5 the machine is in control. The second thing is, in going from one level to the other, it's not always. The effort changes and it increases. And it increases exponentially as you go through the higher levels. It's like the earthquake, the Richter scale earthquake, which earthquakes become much, much more devastating when you go from the high level, of 4 to 5 or 5 to 6, and so forth. And so that's the second point. So it has an exponential increasing, exponentially increases between going from the lower levels to the higher levels. And so I took this model really, and this model I adapted to the testing space, right? So I adapted to the testing to the testing phase, and I created this 5 levels model, which has similar characteristics of the aspects that I just mentioned, right? It's exponential in terms of the level of automation that is needed to go from level 1 to level 2 is smaller than going from level 2 to level 3, and becomes much, much more harder as you go from level 3 to level 4, and level 5, as you can see, there's a big step there because it's very hard to kind of reach that level of automation. The third thing that I forgot to mention in the previous slide, but I can mention it here, is that today in the self-driving cars, we're really at between level 2 and level level 3. And you can see what that means is that basically we're still between partial automation and conditional automation, when the car, based on certain conditions, hands back everything to the driver, says, oh, please, you move on now, because I don't know, suddenly it starts raining, for example. Well, for testing, it's the same. And what this means is that at each level, there's a growing number of bots that are implementing some of the the actions and the steps that a tester would make. So we can start from minimal augmentation and automation, where a tester would leverage, for example, a bot that can generate some unit tests. And by the way, unit test generation, I did position it as being a nice to have, mostly a myth, but in some cases it does become a reality. I have clients that have generated up to 60% of their unit tests with a tool called DiffBlue. And it really, what it depends, the capability of generating more depends on how well you write code. And that's also, by the way, the same consideration for a developer. If a developer doesn't write great code, he's going to have a hard time writing unit tests. Well, the bot, being less intelligent than the developer, will have, of course, even a harder time. So, but if you start from unit testing, you can start generating some unit tests perhaps, or you can generate some semi-automated API tests. And you might not be doing this everywhere in the organization. You might start doing some test out, of course, execution automation. You start doing bits and pieces of these, but with a growing level of intensity and maturing as you go through the steps, right? And all the way to level 4, where you have a bunch of bots. Basically, as a tester, you're managing these bots that are supporting you, even for more sophisticated type of automation testing, like testing for customer experience and usability, and not just the usual functional or unit testing. So you can read this by yourself, and really the way the types of tests that you will bring in will depend a lot on your own journey. But this is kind of the model where the model that I came up with for autonomous testing. Now, the other thing I would say is today we are mostly consider the testing autonomous market between level 2 and 3 as well. And I think that level 5 will, is 30 years away at least. I don't think that I will ever see this happening, but I think it's pretty hard right now. And you can say reassured that I don't think that anytime soon testing bots will replace human beings. So the last thing I wanted to say here is that in terms of, so basically, right, the conclusion is that in leveraging AI and machine learning in testing, testers are being augmented, right? That's the conclusion. We're going to be collaborating with testing bots, with automation, but we are the ones that are going to control and manage it all. And we're going to be augmented as testers. Now, it's augmenting all 3 types of testing personas. I categorize the testing personas in 3, between those that are developer testers that like coding and code and will test and create automation by coding, basically staying in their IDE. Technical testers who are subject matter experts in the testing space that perhaps understand code, but probably prefer scripting or high-level scripting or scriptless environments. And business testers who have who are not technical at all and like to have some abstract level, high-level tool that will help them test maybe user acceptance and business conditions. AI will augment all 3 types of so this is the 3 broad category, right? You can go more fine, we can have more fine granular roles that we can define among these 3, but largely speaking, these are the 3 personas I see in the market. AI will increase testing, will improve testing for technical and business testers, I think, more than it will for developer testers, simply because it's abstracting the level, right? So AI will abstract the complexity, abstract away from the complexity, hiding the complexity, enabling the automation of the complexity, but abstracting the ease, abstracting the complexity away so that also that technical testers and business testers will be more augmented with testing intelligence. So that's the conclusion of that piece of the research. Let's look at the testing of AI. Testing of AI, this is the other stream of research, and there's another, and I already released part 1 of this research at the end of 2019, right? The previous research was done at the beginning of 2019, and it took the whole year to kind of come up with this research, part 1. And so the research focuses around trying to understand how we test AI applications. Now, the AI applications I define as AI-infused applications, because I believe we will be building for the next 5 years at least, what I call AI-infused application. So what is an AI-infused application? Well, it's made of what I call automatic and autonomous. I'm leveraging here an old definition of clog on the autonomous side. What are autonomous applications? What are autonomous systems? Well, or what is autonomous software? It's software that has free will, meaning that it can make its own decision. It makes choices without somebody telling it what to do. In other words, it's learning, right? And that's what machine learning is all about. It's creating these models that can be trained and tested, and then can learn more and more as we give them more data and we train them more. The characteristic of these autonomous systems is that they are non-deterministic. Non-deterministic, they can do predictions, of course, but they're non-deterministic, meaning that same input might generate multiple outcomes. And that's a big problem for those of you and us and me that are used to do testing, build test cases, especially from a business and functional perspective, where we expect exactly for each input a precise output. That's how we write the test cases and what we automate. Well, now we can't do that, right, directly. We can't just, if we have same input, different outputs, that's hard to kind of figure out how to test. The automatic system, so I'm going to call those autonomous, right? That's the autonomous component in an AI-infused application. Automatic systems instead means that the system does exactly what we program it to do. The autonomous system we program to learn. The automatic system, we program exactly what it has to do step by step. I don't need to explain this, what it means, because this is the software you all, and we all have been, for the large part, implementing and coding for the last 50, 60 years since IT has been around. And so it has no choice, it has no free will. And typically that code is deterministic. The algorithms are deterministic. One input, one outcome, one output. Now, what does an AI-infused application look like? Well, basically, it looks like a combination of automatic and autonomous components. As you can see here, the blue components are automatic. We're still going to have a user interface in this AI-infused application. It's going to have a database. It's going to have, it might have a database. It might have, traditional business logic software that we write. It will have integration software, by the way, because it has to integrate these components, but it has to integrate with the autonomous components as well, because being an AI-infused application, it will have infused in, it could have a machine learning model that is providing insights. It might have a natural language generation on LP interface to have an interactive conversational, to enable and fueling an AI chatbot with AI natural language processing. There might be a deep learning model that is recognizing images, and the images is probably could be used by a cybersecurity system for security reasons, recognizing a face, an eye, or a component where RPA is a big topic these days, massively growing. Basically, we're automating more and more processes, and we're making them even more intelligent. And so, and even RPA, of course, and these RPA systems will be combining, integrating with traditional software. So an AI-infused application is basically the software we use to write, but it also is capable of speaking, listening, seeing, sensing, learning, decides and automates and does much more, right? And why do we need, and by the way, the question, of course, is now, so how do we test those? Well, we know how to test the automatic systems. We know that's all the testing we've learned and that we've been doing for all these years, and that now is becoming continuous testing, and we're learning how to automate more, of course. We haven't really solved everything, but we know we have the principles, we've got the technology, we've got the practices, and a lot of that is what we're going to be, you're probably going to be listening in today's event. And developers and testers, know how to test automatic software. On the autonomous side, we as developer and testers know much less on how to test those components. data scientists do some level of testing. They call it validation. They validate the models. As they create these models, they validate that the model, has an outcome that they expect it to have from a business perspective. It's what we would do on unit testing at the unit testing level, perhaps, with some functional testing as well. They call it validation, model validation, but developers and testers don't know much about that. And we don't know how to test the unknown. In other words, and I'll come back to the testing of the unknown in a minute, right? So only 26% of those that are building today AI-infused applications, infusing AI in them or using models, know how to well test those capabilities, the AI capabilities. And I would consider that, especially I would add at scale, right? Maybe one small application, one small model, they can validate the model and that's more than sufficient. However, not really, as you will see when we get into the further details about testing AI, but basically only 26%. So a third, less than a third, less than a third really know how to test AI systems, and the majority are either trying to learn about it, improving, they find it challenging, and 7% find it very challenging. Before I share the framework about how to test and the results of that research about testing AI, why is it that we do need to care about testing an AI-infused application? Well, because those applications that we're building with infused AI is because usually they're involved in strategic decision-making. They are involved in services that have big responsibilities, like maybe lending money or a mortgage, providing a mortgage to someone, in cybersecurity, in security areas, in recommending products. Of course, if you're on Amazon and you get a recommendation to buy something, well, that's not maybe not a big strategic decision. But think about buying, financial products, large investments. Well, then that's a big strategic decision. And AI is being leveraged by human beings to kind of help make better decisions faster. In some cases, they're becoming more autonomous in doing so. But it's also responsible for people's, it's being used in areas where it's responsible for people's lives. Think about self-driving cars. Self-driving cars are very sophisticated. They have hundreds of models. They have a model that will help the car determine if it's, how it recognizing the lane on the freeway, and identifying maybe the different colors and learning about the different colors of the traffic lights. That red means stop, green means go. A neural network that recognizes someone crossing the road, or many of them recognizing someone crossing the road. So lots of perceptrons, as they call them, that are tied, of course, to sensors, but all this is generating data that has to be all coordinated, integrated into traditional software as well, right? Very, very important. I would not jump on a self-driving car if I wasn't sure it was thoroughly tested. And then the biggest important point on this is what we're trying to do with AI is, yes, today it's augmenting people's intelligence, but really, over time, we're trying to pull the human out of the loop, especially in simpler, maybe not in high-risk areas at this point, but the goal is actually to become more and more autonomous. Now, as we pull the human out of the loop in the decision-making, in the leverage of AI, then it becomes even more important to test the AI, I would say, right? Because until a human being might see the response of an AI system and say, okay, I'm not going to consider this because it doesn't sound right. But when the system is autonomously making a decision and taking an action, it's going to become very important to test, right? So, and then last but not least, it's not enough just to say, well, let's just test the outcome. Well, in some cases, it might be too late, but think about a model that recognizes a cat or not. And we do want to know why the model does recognize the cat, or why it doesn't, why it's not working. It's just human being, right? And we want to might know about, why it's making that suggestion. So I guess the point is, why test AI? It's really going to be related to the risk that is involved. The more, the higher the increase of risk we have in AI, the more trust in using it will become critical, and the more in need of testing it we're going to see. So without trust, enterprises can't scale AI. I think that's the big point. If we don't, we've got lots of experiments going on in the enterprises, your own, businesses trying things involved in collaborating with IT, and there's AI centers going, around in the organization trying to experiment and consolidate some applications. That will all not scale at the point when when business users and users start having the impression that there's risk, the systems are failing or are not doing exactly what they expect it to do. And so let me give you an example of how harmful bad testing could be and how it could discourage people from scaling the use of AI. So Compass is a system, a computer-aided system that was built based on machine learning, and that is used by 12 US courts in the United States. This system, in a nutshell, basically what it does is it makes suggestions to the judges about the detention time for prisoners, and it was biased. It was badly biased with by the fact that it would recommend much longer times to detendants that were to prisoners that were of a black color. Rather than the white collar people, it would recommend that actually they have twice as less twice as less the opportunity of recommitting crime, more than opportunity, willingness to recommit crime. This was clearly a bad, bad bias. Now, this is not that bias is, we're not going to eliminate bias from algorithms. Every algorithm has bias, which is the algorithm itself, the person who builds the algorithm, the developer, even in traditional software, I would say. But in the AI side, it's biased because of the data as well, right? It can be biased by the data. But we have to identify the bad bias, right? We have to identify the harmful bias. And that's where that's actually something that testing can do, as you will see in a minute. So testing an AI-infused application really, at the end of the day, means testing the autonomous components and the automatic components and the integration of these. So we're still going to be doing unit testing, non-functional testing, API testing, all the other load performance testing that we know how to do on the automatic software. But we also have to take care of testing the AI components, so the autonomous software. We're going to have to test for bias. We're going to have to test for models that drift in production, because that's what's happened. Once you've trained a model, you put it in production, models drift. And depending on the data, new data, it starts being hit by new data, and therefore it won't recognize that data. It will fail. We need to bring that model back, retrain it with the new data. That's a continuous process, by the way, where testing needs to be involved. So it's testing for identifying the bias, testing the language semantics, the correctness of language, the translations, the understanding of it, the voice transcription. We do a pretty good job in voice transcription. You can see that when you use Alexa, but think about, understanding the semantics, and is it telling me the right thing? Is it using the right language that a business, that a bank would want a bot to use with its clients? It's not going to let the bot just, use any types of words. And then there's also speed issues. Today, we all know that if a page doesn't show up in 3 seconds, I'm going to lose interest in even looking at that page, and maybe I'll go to another website, and people lose business for this. Well, it's going to be the same for AI. If a system is a chatbot and it has to provide you a response, written response, or even a voice response, it will have to do that in very short term, within seconds. So we have to test the load performance of the component, or even the load performance of the end-to-end, the end-to-end autonomous and automatic software components that are being traversed by user experience. Now, another important aspect is that not all of the testing of an AI is going to be the same and same, huge effort or smaller effort. It depends what level of AI you're using. As I said, right, the sophistication of the deep learning models that you might be using for image and video, and voice, it's mostly deep learning. How do you, the language semantics correctness, this might be even harder. And then there's a big difference between testing the autonomous components that we build autonomous ourselves, right, by using a TensorFlow library, for example, versus using those models can drift, and versus using the pre-trained models through APIs. In other words, the services, the AI services that companies like Google, Amazon, Microsoft, IBM, and other companies offer for us to build and leverage voice recognition, image recognition, and other interesting and other models. And some of these models are more opaque than others, harder to test and understand than others. So it's not all going to be at the same level of complication. And then the real hard part is testing what I call the end-to-end generated outcome of both the automatic and autonomous. How do we test an AI-generated experience? And the reason why this is hard is because an AI-generated experience, we probably didn't, it's not like in testing where you can create the test case because you know what it's going to do. But here, you don't know what it's going to do. So generated AI experience is hard to test. All right, so we know everything about testing automatic software, and I've written much about this. I think I spoke about this last year at the Sauce conference of 2019. It's all the usual types of testing you all know about. You know that we're working on, and we need new practices. Organizations that are doing modern testing, continuous testing, are introducing new practices. They are reorganizing in a different way. They are leveraging a modern technology stack and technologies that focus on automation, on API, on CI/CD, and so forth. I'm going to take all this for granted, and you're probably going to hear a lot of all this in the rest of the sessions, as I said earlier, of this virtual conference, which is all about continuous testing. But let's look at the testing of an AI-infused application. So, all right, so basically, you've got the automatic components, which can be self-built or packaged. We know everything about that, and we just apply all the types of testing. So what I did in the research is I mapped the types of testing of the world we know into trying to find out, what of that can be used for testing an AI-infused application. The good news is that actually more than 80% in some cases is leveraging the skills we know, the types of testing we know, and the types of testing tools that we can use for doing the testing of an AI-infused application. Now, the autonomous components are these three boxes down here. Self-built autonomous models. We can start, so the self-built, if you're building the autonomous model, you will end up doing some unit testing, functional testing, integration testing, because the model has to be integrated into the rest. There's this data testing layer, which is very important. I'm going to come back to that. So, but basically what this is showing is that there's a lot of the types of testing that we know today that can be leveraged by to do self-built, autonomous models in an AI-infused application. For the consumed, pre-trained autonomous models, it's like packaged application software on the traditional world. You won't test SAP code. You will test SAP if you're using SAP or Salesforce or something else, just by, you want to make sure that the data, it works with the data, your business data. So you'll do data testing, but you won't test that the actual code, is wrong or right. That's something that SAP or Salesforce are doing. Well, for the models, when you're consuming pre-trained models, we're hoping that, IBM, Google are doing an exhaustive testing on those models and making sure that they're working at the unit level, the validation of the models, right? And you will be eventually leveraging and consuming through the APIs, the outcomes of the models. So it's like, test it with your data. Does it work? Does it recognize the data that you train it on? And then there's this end-to-end autonomous and automatic behavior, the whole end-to-end experience of an AI-infused application that includes this unknown testing. I'm going to come back to the unknown testing, as I said. I promise. I'm going to just go quickly through the framework in more detail. We're not going to look at all of this, all the details on this, but just take a look at the two columns, AI ML components and AI-infused applications. And basically mapping the different types of testing into the autonomous components. So basically you can see that unit testing is what we call in the software world is what the data scientists would call validation of the models. And so it's done by the data scientists. This is what I do in the framework. I just kind of describe what it is, what the skills needed are, who's the persona doing it, and what the tools are. So data scientists would do the what we call unit testing. They might call validation, but some of them call it also unit testing. The persona is the data scientist, and there's some tools already available. The FairML or the F1 score metric for accuracy of models. The AI Fairness 360 toolkit that does also some bias testing on the models. And then you have to test the combination of the model with the rest of the software. So you look at the column AI-infused applications testing. In the functional testing space down here, you can see that the skills are really both sides of data scientists and collaborating with the software tester. So this is where they need to collaborate, the two roles, or the data scientist with the model understanding, the AI understanding, and the technical tester. Now, what I've seen also is that sometimes technical testers are learning about machine learning and doing this themselves. Typically, functional testing can be used for the bias, for testing for bias, for limiting the bias of an outcome of a model. If the model drifts and we don't capture the bias in the model itself, but there's a safeguard, functional test we can put around it to stop it from taking in consideration bad bias. And the tools used for functional testing are the ones we know, right? Are the conventional testing tools from functional testing tools from the traditional world. Load performance testing, again, the tools come from the conventional world. This requires performance engineering skills, performance engineers and developers mostly. The only thing is they kind of have to get the business needs from the speed needs, requirements needs from the data scientist perhaps, or from the business, the person involved in building, in requiring the AI component. In the AI-infused application, in the large, the performance will be a little bit more comprehensive and requires more performance engineering skills. I would say it's one thing to test just a component, it's one thing, a model, and it's another thing to test the model interacting with the rest of the software. Integration testing is another area. Again, we can leverage the skills from the testing world. It's non-functional testing. It's coming, the persona is a technical and developer tester. The tools that can be used are the service visualization conventional tools we use in the software market, with open source frameworks as well. Very important to use, especially when the models are running on specialized hardware. We can simulate, virtual assets that will simulate the behavior of the model and be considered in the integration testing. So data testing is the other big area, governance of data. This is a big area actually that merits a session on its own, but there's a lot of work in making sure the amount of data that is coming from, that to train a model, there's a whole governance process to do that, but there's traditional TDM, test data management tools that can help. And they can be used. And it requires both the combination, I would say, skills of business and data scientists together with the technical testers. Monitoring in production, as I mentioned earlier, sometimes these models in production will drift, so they need to be monitored. I call that testing in production. They might gain some, bias, and we want to make sure that we capture that. And when we capture that, we get the training, we get the model, we bring it back, we retrain it, and we deploy it again. So testing, monitoring in production is is another important area. And the last one is unknown testing. And what unknown testing really means is, how do we test an AI-generated experience? Well, that's what I'm currently working on. There's a report, the No Testing Means No Trust in AI Part 2 that I'm working on. I don't have the full results, but I can tell you, and it's coming soon, but I can share with you some initial findings. One, that basically the unknown, we try to make the unknown known, right? We've got experienced designers and testers that are collaborating. We know that the experienced designer will probably help design a perimeter within which the tester will have to operate and not go outside of it. And so therefore, because we know that a business won't allow, for example, certain policies to be just created by an AI system, it will have to be safeguarded. So with the early involvement of the designer, experienced designers and testers collaboration, probably there's some testing that can be done there to avoid avoid a system from creating the unknown without control. Lots of simulation testing in the self-driving cars. This is happening. This is being used. There's lots of simulation that is used. You know, cars are not tested just on the road. And then there's this hypothesis that only AI can test AI, especially in a very complex situation. Probably we need to build AI systems that are testing another AI system and controlling it, right? It's like, that might be expensive, but worth it in certain very high risk areas. Like in trading systems, it looks like this is an approach that is being taken. And last but not least, all this testing, continuous testing, has to happen on a AI, continuous integration, continuous data software pipeline that will enable the testing of these models and of both the automatic and the autonomous components, but also be able to pull the model back from production and have this continuous testing happen on a software delivery pipeline that is managing both data and software all together. And that concludes my speech on this. I thank you very much for your attention and enjoy the rest of the event. Thank you. Bye-bye.